Okay, one of my favorite examples of MapReduce, whenever you feel that, oh, this problem is too difficult to implement as a MapReduce, I really need to iterate. I need to write a for loop. And there are many times you'll be stuck with a problem that says, oh, this problem cannot be solved using MapReduce. It's impossible. I need to do iteration. One such problem is cumulative precipitation. So let's say your goal is to create a chart like this. Let me just first run this and show you. I want to create a chart like this. Cumulative precipitation for a year. So you start your first year with 0 precipitation, and as you accumulate precipitation, your chart goes up, right? And you can use this. This is used widely in hydrology to determine, when the rainy season starts or when the rainy season ends, and so on, right? There are many variables you can derive from this. So if you want to create a chart like this, you would say, oh, I need to compute the precipitation for July 28, cumulative precipitation. That means I need to know what happened on July 27, right? Then only I can compute that. So, and to compute this, I need to know what happened before. So I need to take each image and process them sequentially. Then only I can get this chart. Right? So this is a classic example of something that is, intuitively not amenable to parallel computing, because you can't compute each value independently. You need the previous value computed before you do this one. And people kind of, when they encounter a similar problem, they'll reach for this function called iterate in Earth Engine, where you kind of write this and you'll compute one image, get the result, send you the second image, and so on. If you did this with iterate, it's going to be super slow. It's going to take 365 global images and iterate over this to compute this value. Can we do this in parallel? Okay, so again, when I show the solution, it's going to be very simple. But when you have this problem, think of how can I compute each value independently without knowing what was the previous value. One simple way to do this is, what is the precipitation on cumulative precipitation on August 11? Well, it's a sum of precipitation from Jan 1st to August 11. I don't need to know what happened in August 11. Just can take all the images and sum it up. For August 13, it's a sum from Jan 1st to August 13. So if you see the script, that's what the script is doing. You have a start and end date, and you compute the number of days using the date API. You have a list of days, and you map a function on each day. So day starts with 1. Start date.advance 1 day, compute the sum. Start.advance 2 days, compute the sum. Start.advance 100 days, compute the sum. And each function can run independently for each day and compute the cumulative precipitation up to that day independently of each other. And finally, when you run this, you will get this chart in like 1 second anywhere in the world, right? Because it can do this in parallel. So again, it's a cumulative computation, but we did each step independently using MapReduce. So again, try this out and see if you can understand and apply similar concepts as well. So barring a very, very few cases, I've not encountered any examples where you cannot solve this using MapReduce. It just requires a slightly different way of thinking. So again, whenever you feel yourself that, okay, I really need to write a for loop or I cannot do this, think of this example and say, if we can do this using MapReduce, it is going to be possible.